Can you explain the time and space complexity of the logic you produce today? Do you know if it is the most efficient version possible? Investing in algorithmic mastery allows a developer to move from a defensive position to one of career autonomy.
Mastering data structures and algorithms allows an engineer to solve novel problems that AI, which relies on existing patterns, is not yet equipped to handle. This represents a shift in the profession.
When an engineer can solve a company's most expensive resource and optimization issues, they become a structural necessity. They are no longer a replaceable cost, but a primary driver of efficiency.
These assessments measure how well a developer can untangle a complex resource problem and minimize the compute time required to solve it. In this environment, failing to clear these algorithmic benchmarks results in immediate disqualification. No amount of past experience or impressive titles will bypass a failed technical evaluation.
This skill is not innate. It is built through a systematic three-step process designed to change how a developer approaches a problem. Step 1 is internalizing foundational data structures. You must understand how data is stored in arrays, trees, and hash tables, and how to efficiently manipulate it. Step 2 is applying this theory to build engines, like a pathfinding application, that require these algorithms to function. Step 3 is observing how these mechanics govern the industry.
Over the last year, the tech industry has seen a massive consolidation, displacing workers at a scale not seen in a decade. In the middle of this contraction, a small subset of engineers is seeing the opposite. They are moving into senior roles and securing substantial salary increases.
Companies are no longer cutting at random. They are identifying and removing roles focused on manual data movement, routine basic testing, and boilerplate syntax. Because AI models can now generate predictable code patterns instantly, developers who only produce that same repetitive syntax find themselves in direct competition with a cheaper, faster automation. If the ability to write code is no longer enough to guarantee a role, what specific trait makes a developer resistant to these cuts? Survival in this new market requires a shift from writing syntax to architecting logic.
Software engineering is moving away from rote coding and toward the design of complex, optimized systems. Corporations are raising their standards. They're prioritizing the hire of problem solvers over those who simply understand a specific programming language. AI can automate the low-level tasks of a developer's day, but those very automation models are constructed using the same algorithmic principles that are now used to evaluate human talent. Developers who understand these underlying mechanics move from being a user of the tool to someone capable of optimizing and scaling the systems the tool runs on.
To find these specific engineers, tech giants have standardized their hiring pipelines to mathematically filter for logical performance. Platforms like LeetCode and HackerRank act as the technical mesh filter. Thousands of applicants enter the funnel, but only a few proceed past the algorithmic assessment.
This means studying how distributed systems and modern machine learning models rely on these same principles to operate at scale. To find the weaknesses in your own understanding, try to explain these concepts to a junior developer. Teaching forces you to reconcile any logical gaps you may have glossed over while studying. Completing this process changes your technical methodology.
You stop reaching for the first syntax that works and start designing the most efficient solution before writing a single line of code. The results of this shift are documented. Even in a down market, algorithmic proficiency consistently bypasses traditional hiring barriers.
Consider Rahul, an engineer with 5 years of experience who was laid off in 2023. By spending his transition period solving hundreds of algorithmic challenges, he was able to secure a new role with a 40% salary increase.
Or consider Priya, who lacked a computer science degree and came from a commerce background. She bypassed the traditional academic filters by proving her logical ability through high-level algorithmic practice, eventually securing a position at Google.
These examples show that the industry selection process is increasingly blind to pedigree, favoring those who can demonstrate pure structural logic and optimization skills. You cannot control the economy or the decisions of a board of directors. You can, however, control the depth of your own technical utility